Hey guys, welcome to Learn Today IGCSE. This video is on Chapter 2, Atoms, Elements and Compounds. There are two parts for this video. First, we will go through the key concept of this chapter, and next we will try to answer some questions from past papers. In this chapter, we will be discussing on elements, compound mixtures, atomic structure and periodic table, isotope, and the four types of main bonds. First, we're going to start off by remembering the main terms, which are elements, compounds, and mixtures. Elements are a substance which contain only one type of atom, and they cannot be split into anything simpler by any chemical means. The periodic table is dedicated for all the elements that exist on Earth. So, all the symbols that you see in your periodic table are considered as one element. Moving on to compound. Compound is a substance made up of two or more elements which are chemically combined. And on the other hand, mixture is a substance made up of two or more elements. The only difference is that it is not chemically bonded together. Be sure to memorize and understand these terms clearly. Now, an element can exist in the form of an atom or a molecule. An atom is the smallest particle of a chemical element that can exist, whereas molecule is two or more atoms which are chemically bonded together. Neon is an element from group 8 which exists in this form, whereas chlorine is in group 7 and it exists in the form of a molecule. And now when we look closely at the structure of an atom, the central nucleus of an atom contains neutrons and protons, and they are surrounded by shells of electrons. The relative charge and mass of proton is 1. The charge of neutron is 0 and its mass is 1. Since they are both found in the nucleus, this makes the overall charge of the nucleus positive. And next, electrons have the charge of -1 and the relative mass is 1 over 1836. When you look into your periodic table, you would see that there are numbers at the top and the bottom. In your periodic table, they have already mentioned that the most top number defines the atomic number, followed by the atomic symbol, which is H, the name of the element, which is hydrogen, and lastly at the most bottom, you have the relative atomic mass. So let's look at what all of this mean. Atomic number is the number of protons that is present in the nucleus of an atom. Next, you've got mass number. Mass number is the total number of protons and neutrons that exist inside of the nucleus. And next, we've got nuclear number, which is the same as mass number. The number of neutrons can be calculated by taking the mass number and minus with its atomic number. Now, in the structure of an atom, the maximum number that can fill up the first shell are 2 electrons, and the maximum number that can fill up the second shell and other shells are 8 electrons. For example, neon has proton number of 10. This means that it also have 10 electrons. So out of the 10 electrons, the first shell can only accommodate 2 electrons. So 2 electrons go into the first shell and the balance 8 electron goes into the second shell. If you have an element with 11 proton numbers, you will also have 11 electrons. So on the first shell, you will have 2 electrons. So the balance would be 9 electrons. The second shell can only accommodate a maximum of 8 electrons. So that leaves us with 1 more electron, which goes on the third shell. This is how we write electron configuration. Looking at the electron configuration, there are two things that can be determined. The number of electrons in the outer shell can tell you the group number of the element. So neon here would be in group 8 since the last number is 8. And the number of shells that they contain, for instance, neon has 2 shells, will tell us that neon is in period 2. Next, moving on to isotopes. Isotopes are atoms of the same element with the same number of protons but different number of neutrons. Since isotopes are of the same element with the same number of protons, this means that it also have the same number of electrons, which makes them to have the same chemical properties. The relative atomic mass can be calculated by taking the average mass of the isotopes compared with 1/12 of the mass of an atom of carbon. Please remember the definition of relative atomic mass. So to calculate the relative abundance of the particular isotope, we're going to take the percentage of the isotope and multiply by its mass. And you repeat the same thing for all the isotopes that are present, sum them all up together and divide it by 100. We will look into some past papers later on, then you will see how to apply this formula. Next, moving on to bonds. This is the summary of 4 different types of bonds that we are going to learn. Firstly, we've got an ionic bond. An ionic bond is a strong electrostatic force of attraction between oppositely charged ions which are formed between a metal and a non-metal. An ion is formed when an atom loses or gains electron. If it loses an electron, it will form a positive ion which is known as cation. And if it gains electron, it would form a negatively charged ion which is known as an anion. As mentioned previously, the maximum number of electrons that a shell can hold is 8 electrons. And if it doesn't hold 8 electrons, it means that it is an unstable atom, which will then either lose electron or gain electron to achieve stability. In this case, instead of receiving 7 electrons to become 8 electrons, it will be easier to lose the electron. And as for chlorine, to achieve stability, it is easier to just gain 1 electron to become 8 instead of losing 7 electrons. So as you can see here, sodium needs to lose an electron, whereas chlorine needs to gain an electron. So sodium can donate its electron to chlorine atom. So the new electron configuration for sodium would be 2.8 and for chlorine is 288. As you can see, the last shell is filled with 8 electrons, so now both of them are stable. Since sodium has lost an electron, it will become a positively charged ion. And the charge is positive 1 because it lost 1 electron. And for chlorine, since it gained an electron, it will become a negatively charged ion and the charge would be negative 1 since it gained only 1 electron. And this is how an ionic bond is formed. The properties for an ionic bond is that it has high melting point and boiling point. The reason is due to its strong electrostatic force of attraction, which requires a lot of energy to break them apart. Next is that it does not conduct electricity because it does not contain any free-moving electrons to carry charges. However, it does conduct electricity when in molten state or dissolved in an aqueous solution, because in this state there are free-moving ions, so they can carry electric charge. And lastly, ionic compounds are brittle because when force is applied, it causes the ion to move, which then causes the same charges to align and repel, and therefore this lattice structure will be broken apart. Next, moving on to metallic bond. Metallic bond is the electrostatic forces of attraction between positive metal ions and a sea of delocalized electrons. For example, iron, zinc, aluminum, or other metals. The properties of metallic bond is that they are good conductors of heat because they have delocalized electrons which are free to move. Therefore, heat energy can be transferred throughout the structure. Next, it can conduct electricity because there are free-moving electrons which can carry the charges. The reason for conduction of electricity is always depending on whether there are free-moving electrons or not. If there are free-moving electrons, then it can always carry charges. That means they can always conduct electricity. Next, it has high melting and boiling point. Remember that high melting and boiling point depends on the force of attraction. If the compound consists of a strong force of attraction, it is going to require a lot of energy to break them apart. That is the reason why you have high melting or boiling point. Next is that it is malleable. Malleable means easy to shape. The reason is because the layers of ions can slide over each other. And lastly, it is ductile. And the reason is the same, due to the layers of ions that can slide over each other. Next, moving on to simple molecules and covalent bonds. If you are asked to define a covalent bond, remember that covalent bonds are strong electrostatic forces of attraction between the nuclei, which is positively charged, and the shared pair of electrons, which are negatively charged. A covalent bond is formed between two nonmetals. For example, chlorine is a nonmetal and both of them are unstable. So when they combine together chemically, they will form a covalent bond. Both chlorine atoms need one electron to complete the outer shell. So their outer shells are going to overlap with each other to share their electrons. So if you look at the atom individually, you would see that it has a complete 8 electrons on its outer shell, therefore resulting in a noble gas electron configuration, which is 8 electrons. The properties of a covalent bond is that it has low melting and boiling point. As mentioned previously, melting and boiling point depends on the forces of attraction. Since it has low melting and boiling point, this is due to weak intermolecular forces of attraction, which does not require much energy to overcome. Next, it has poor electrical conductors. because it has no overall charge, meaning that there are no free moving electrons to carry charges. Lastly, we've got giant covalent structures, which are large lattice of covalently bonded atoms. There are 3 examples for giant covalent structures that you have to know. The first one is silicon dioxide, where each silicon atom is bonded covalently to 4 oxygen atoms, and each oxygen atom is bonded covalently with 2 silicon atoms. Next, you've got diamond, and this is the structure of a diamond. However, diamond can also exist in a different form. When it exists in a different form, you can identify it as an allotrope. There are 2 allotropes. One is diamond and the other is graphite. Now, both diamond and graphite has high melting point due to its many strong covalent bonds and require a lot of energy to break them. Even though graphite can conduct electricity, on the other hand, diamond is not able to conduct electricity due to its no free moving electrons. And the last property for graphite is that it can be used as lubricant. Due to the structure of graphite, which are arranged in layers, therefore they can slide over each other. Now, the similarities between silicon dioxide and diamond is that both of them are giant covalent structures. Both of them have very high melting points due to its strong covalent bond. Both of them are hard structure, and both of them are not able to conduct electricity. Alright, that's a brief summary of this chapter, and now let's practice on some past paper questions. The first question is about atoms. Atoms are made of protons, neutrons, and electrons. Atoms of the same element are known as isotopes. Complete the table. So you are asked to fill up the relative charges and the mass of electron, neutrons, and proton. So as we have discussed earlier, we can just fill in our answers. Electron has a charge of -1 and neutron is 0. The relative mass of neutron and proton are both 1. Next question, part 2. 24 magnesium and 25 magnesium are isotopes of magnesium. Complete the table to show the number of electrons, neutrons, and protons in these isotopes of magnesium. Since they are isotopes, they will have the same number of proton, which is 12. And we can see that there are no charges, meaning that they are not an ion. So this tells us that both these magnesium are atoms. Atoms have the same number of protons and electrons, so we'll fill in 12 over here. Now remember that the top number represents the mass number, which is the total number of protons and neutrons. So 24 equals to the sum of proton plus neutron. The number of proton has already been given, which is 12. So this means that the number of neutron is 24, take away 12, which is 12 as well. And now we'll repeat the same thing for the other isotope. The number of neutrons will be 25, take away 12, which is 13. So the answer is 13. Next, part 3. Explain why magnesium ions have a charge of +2. Magnesium atom has an electron of 12. So this means that 2 electrons go on the first shell. The second electron can only occupy a maximum of 8 electrons, leaving us with 2 more electrons on the final shell. As we have discussed previously, to achieve stability, it can either lose 2 electrons so that it has an outer shell of 8, or gain another 6 electrons so it has an outer shell of 8. Losing 2 electrons will take less energy compared to gaining 6 electrons. So that's what's going to happen here. The magnesium atom will lose 2 electrons. This means that it will only be left with 10 electrons. However, the proton number will remain the same. In the nucleus, you will still have 12 protons. But now on the shell, you only have 10 electrons. So the reason is due to having 2 more protons than electrons. Question B. Magnesium 2 plus ion have electronic structure 2,8. Give the formula of the following particles which have the same electronic structure of Mg2 plus ion. So we are looking to find for a positive ion that also have an electron configuration of 2,8. To be a positive ion, it means that it has donated the electrons on the outermost shell. So we're looking for an element which previously has an electronic configuration of 281, 282 or 283. So the elements would be either sodium, magnesium or aluminium. So sodium donates 1 electron, the charge is positive 1. Magnesium 2 electron plus 2 and aluminium 3 electron plus 3. Next is an anion which is negatively charged. So we need to find which ion has reached an electron configuration of 2,8. Remember, a negative ion means that the outer shell has gained electrons in order to become 8. So previously it could be 2,7, 2,6, 2, 5, or 2, 4. It can't be 2, 3 because 3 means you lose electron. That would be a positive ion. So we are going to look at which atom these are. So these are the 4 elements with configuration of 2, 4, 2, 5, 2, 6, and 2, 7. So in order to become stable, carbon will receive 4 electrons, giving you a charge of 4 minus. In order for nitrogen to be stable, it will receive 3 electrons, giving you a charge of negative 3. Oxygen 2 electrons with charge of 2 minus, and fluorine 1 more electron with the charge of 1 minus. So these are the 4 examples that can have the same electron configuration as 2, 8. And lastly, an atom. An atom means it has not gained neither lose an electron. We need to find an atom which has electronic configuration of 2, 8, which is a total of 10 electrons, 2 and 8. So the atom would be neon. Table 2.1 gives information about particles A, B, C, D, and F. You're given with the electron numbers, the neutrons, and the protons. If you sum the neutrons and protons, you will get the atomic mass. Alright, question A. Give the letters of all the particles which are atoms. Remember that an atom means that the number of proton inside of the nucleus will be equal to the number of electrons on the shell. And the particles that have the same electron number to its proton is particle A, B, and F. Next question, part 2. Ions with a charge of 2 minus. 2 minus means that the atom has gained 2 electrons to achieve stability. So this means that it has 2 extra electrons compared to proton. Particle C have 3 less electrons compared to proton. This means that the charge is plus 3. Particle D has 2 electrons more than proton. It means that it is minus 2. Particle E has 1 extra electron compared to the proton. So this is minus 1. So the answer for part 2 is going to be particle D. Next, part 3, cations. Remember that an atom that has lost electron to become positively charged is identified as cations. So the positively charged particle here is only particle C, which is positive 3. Next, question B. State the atomic number of A. Remember that atomic number is the number of protons. So we can just get the number of protons from the table here, which is 5. Next, determine the number of nucleons in D. The atomic mass is the nucleon number, which is the sum of protons and neutrons. So the sum of proton and neutron in D would be 16 plus 17, which is 33. Next, question D. State the electronic configuration of D. To do the electronic configuration, we need to see how many numbers of electrons are present for D. The number of electrons are 18. So the electron configuration will be 2 for the first shell, 8 for the second shell, and the final shell will be 8. If you sum this all together, you would get 18 electrons. Question E. State the group number of F. So to identify the group, we first must find the electronic configuration. We have got 15 electrons. So the electron configuration will be 2 for the first shell, maximum of 8 for the next shell, which sums up to be 10 electrons. So we are left with another 5 electrons which will go on the last shell. So the valence electron here is 5. This means that the group is 5. Next, question F. State the period number of B. B has 10 electrons. So that means the electron configuration is 2 and 8. Since there are only 2 shells, the period will be in period 2. Remember that the valence electron determines the group and the number of shell determines the period. Boron and aluminium are group 3 elements. Question A. Boron A has only 2 naturally occurring isotopes, 10 boron and 11 boron. This question is regarding isotopes. Isotopes are atoms of the same element with the same number of protons, but they have different number of neutrons or a different mass number. You are asked to complete table 2.1 to show the number of protons, neutrons, and electrons in an atom of 11 boron. The top number here represents the mass number, which is the sum of proton number and neutron number. To get the proton number for this atom, we can look into the periodic table of elements. The proton number for boron is 5. So proton number is 5. Since this is an atom, the proton number will be equal to the electron number. So the number of electrons are also 5. As for the number of neutron, we can get that by taking the mass number minus the proton number, which is 5, giving us 6 neutrons. Okay, next. Question B. The relative atomic mass of boron to one decimal place is 10.8. The relative atomic mass can be calculated by taking the average of both isotopes. The isotopes that we have is 10 boron and 11 boron. If we take 50% of 10 boron and 50% of 11 boron, we will get a mass of 10.5. So we can use a little bit of mathematical skills to get the answer for this question. Since the final mass is 10.8, this means that there are more percentage for 11. So we can use 80% of 11 and 20% of 10 boron. We will get a relative atomic mass of 10.8. So the percentage of 10 boron is 20%. Next, cobalt and copper are transition elements. Transition elements are the elements that are present from group 3 to group 12. Question A. Copper have two naturally occurring isotopes, 63 copper and 65 copper. Cobalt has only one naturally occurring isotope, which is 59 cobalt. Part 1. We are asked to complete the table to show the number of protons, neutrons, and electrons in 59 cobalt and 65 copper ion. Alright, so the element present here is cobalt and copper. Let's first find out the proton number for these two elements in the periodic table. The proton number for cobalt is 27 and for copper is 29. Now, since cobalt do not have any charges, this means that cobalt is an atom. And as we discussed previously, an atom means that the proton number and electron number are the same. So this will also be 27. Now let's look at the neutron number. If the total mass is 59, minus the proton number will be the neutron number, which is 32. Now let's look at copper ion. This means that it has donated 2 electrons. If it has 29 proton, it means that initially it also have 29 electrons. But after donating 2 electrons, now it is left with 27 electrons. And now we can look for the neutron number. 65 is the total mass minus the proton number, which is 29, will give us 36 neutrons. Next question, part 2. Table 2.2 shows the relative abundance of the two naturally occurring isotopes of copper. Calculate the relative atomic mass of copper to one decimal place. Okay, this is much simpler. We just have to apply the formula. So 70% multiply the mass of the first isotope, add with 30%, multiply the mass with the second isotope, divided by 100. You can put all this value in your calculator and you will obtain a relative atomic mass of 63.6. Alright, next let's move on to atoms, elements, and compounds. This question is about ionic and covalent compounds. Question part A1. Sodium reacts with oxygen to form the ionic compound sodium oxide. The electronic configurations of an atom of sodium and an atom of oxygen are shown in figure 3.1. So here you have sodium at 2 on the first shell, 8 on the second shell, and only 1 on the last shell. And then there's oxygen, 2 electrons on the first shell and 6 electrons on the second shell. Ions are formed by the transfer of electrons from sodium atoms to oxygen atoms. Complete the dot and cross diagram in figure 3.2 to show the electronic configuration of one sodium ion and one oxide ion. Show the charges on the ions. Alright, remember, when your valence electron end with 1, 2, or 3, you're always going to donate the electrons. So we are going to donate 1 electron over here. If we donate the electron, the charge would be positive 1, leaving us with only 2 shells remaining. So the new electron configuration is 2, 8 because we have lost or we have donated 1 electron. Now next, the valence electron is 6. If the valence electron is 4, 5, 6, and 7, you're going to gain electron until it becomes 8. For this to become 8, you're going to have to gain another 2 electrons. So the charge of the ion would be minus 2. Originally, you have 6 electrons. So after gaining 2 more electrons, you would have an electron configuration of 2, 8. Next, part 2, write the formula of sodium oxide. Okay, we haven't really gone through this in our notes, but we can still do this. Sodium has a charge of +1, oxygen has a charge of -2. So in order to come up with the formula, we're going to just take the number, not the charge, just the number and cross it to the other side. So your formula would be Na2O. Next, part B. Carbon dioxide is a covalent compound. Remember, a covalent compound is when two nonmetals chemically combines. Complete the dot and cross diagram in figure 3.3 to show the electronic configuration in a molecule of carbon dioxide. Show only the outer shell electrons. Alright, we have the element of carbon and oxygen. The first thing that you should do is get the electron configuration for these two elements. Carbon has 6 protons and oxygen have 8 protons. Since they are atoms, they will also have 6 electrons and 8 electrons. Now 6 electrons means the configuration is 2, 4. 8 electrons means the configuration is 2, 6. So for carbon, you have 2, 4. The outer shell consists of 4 electrons. And as for oxygen, the outer shell consists of 6 electrons. So let's say carbon has 4 electrons and we will draw them like this. And oxygen have 6 electrons on its own. Let's draw like this. Try not to draw anything in the center at the beginning. For oxygen to be stable, it's going to need another 2 electrons. So what we can do is we can take the 2 electrons from the carbon and place it over here. We take the 2 electrons and we place it over here instead. So this way, carbon is sharing 2 electrons on each side with oxygen. So as you can see, if you look into oxygen individually, it has a complete of 8 electrons. However, carbon only have 4 electrons. It means that it needs another 4 electrons. So it can take 2 electrons from oxygen on each side. So we take 2 electrons from oxygen and we put it here. Take 2 electrons from oxygen and we put it here. Now if you look at carbon individually, it has a complete 8 electrons. Oxygen has a complete 8 electrons. Also the oxygen on this side has a complete 8 electrons. So the idea of drawing covalent compound is to ensure that you share the electrons with one another. Alright, let's try another dot and cross diagram first for ionic compound and then we will try another one for covalent compound. So we have got potassium oxide. Potassium has an electron configuration of 2, 8, 8, 1 because it has 19 electrons. And oxygen has 8 electrons, so the electron configuration is 2, 6. Remember, if it lasts with 1, 2 or 3, it's going to lose the electron to form a positively charged ion, leaving you with 2 on the first shell, 8 on the second shell, and we are going to draw another shell filling up with 8 electrons. And we'll repeat the same thing for this ion. Alright, now let's look at oxygen. Oxygen has the second shell filled up with 6 electrons. So we will draw 6 electrons on the outer shell. In order for it to become complete 8, it needs to gain another 2 electrons. So the charge would be -2. So these 2 electrons that it gained will come from potassium. They donate 1 from each. So we will take 1 electron from potassium and put it here, and 1 electron from potassium and put it here. So this is what the cross and dot diagram look for an ionic compound. Now we will try another one for covalent compound. Before drawing, let's identify the elements that present, silicon and chlorine. Next, let's write down their electron configuration. From here, we can see that silicon needs another 4 electrons to be stable, whereas chlorine needs 1 more electron to be stable. Okay, now let's fill in their outer shell of electrons. As silicons have 4 electrons, we will place their electrons lying on the chlorine atom to show that they are sharing with chlorine. And now we will continue drawing the electrons on chlorine atom, which consists of 7 electrons by its own. When filling in the electrons for chlorine, we should make sure that one of each electron falls into the shell of silicon. And as you can see here, 4 electrons are shared from chlorine to silicon since silicon needs 4 more electrons to be stable. Individually, each atom will have a complete 8 electrons on its outer shell. Alright, now let's try some question on physical properties for ionic and covalent compounds. This question says that one physical property typical of ionic compounds, such as magnesium chloride, is that they are soluble in water. Give 2 other physical properties that are typical of ionic compounds. So you can mention any of these 4 properties. Part C. The melting points of sodium oxide and carbon dioxide are shown in Table 3.1. Part 1. Explain in terms of bonding why sodium oxide has a high melting point. When explaining in terms of bonding, you can start by stating the type of ions the compound consists. Sodium oxide has positive ions and negative ions. And then explain about the type of bonds or forces that exist within the compound. Sodium oxide has strong ionic bonds, which you could also describe as electrostatic force of attraction. Since the question only provides you with 2 marks, these 2 points are sufficient. Likewise, if they were to ask you about carbon dioxide having a low melting point, you can say that it consists of negative ions and that it has weak intermolecular force. Part 2. Carbon dioxide has a low melting point. State the general term for the weak forces that cause carbon dioxide to have a low melting point. So as I mentioned before, for high melting point it has strong ionic bonds, and for low melting point, the compound consists of weak intermolecular forces. Question C. The melting points of silicon tetrachloride and silicon oxide are shown in Table 3.1. Part 1. Silicon tetrachloride has a low melting point because it has weak forces of attraction between particles. Name the type of particles that are held together by these weak forces of attraction. The type of particles are known as molecules. Part 2. Explain, in terms of structure and bonding, why silicon oxide has a high melting point. When explaining in terms of structure and bonding, you can start by stating the type of compound it has. Silicon oxide is a giant covalent structure. Next, mention the type of bonds or forces a giant covalent structure has. Hence, it requires a high energy to break the bond between the particles. Since you're only given with 2 marks, the first 2 points are sufficient. You can mention the third point if you're given with 3 marks. Alright, one last question on metallic compound. This question is about sodium and compounds of sodium. Question 8 part 1. Describe the bonding in a metallic element such as sodium. You may include a diagram as part of your answer. So if you recall previously, this is how a metallic bond looks like. You have positive metal ions that is surrounded by a sea of delocalized electrons. So since this is on sodium, you can just write the symbol of sodium with the positive charge and show that it has a sea of delocalized electrons. As for the description, you can say that it has a regular pattern of positive sodium ions which is surrounded by a sea of delocalized electrons. And a metallic bond, it is held by a strong electrostatic force of attraction between positive ions and negative electrons. This is how you can gain a complete 3 marks. Next, part 2. Describe how solid sodium conducts electricity. Remember, I have mentioned previously that whenever you are asked about conduction of electricity, if the material can conduct electricity, the reason is always the same. Due to the delocalized electrons, meaning that these electrons are free to move. If it is free to move, it means that it can carry charges. So for 1 mark, you can just mention free moving electrons. Question 2 onwards is from chapter 2. Which statements about clean dry air are correct? This here is the composition of air. Number 1 says that it is a mixture of elements only. This is not correct because 0.04% of dry air is made up of carbon dioxide, which is not an element but a compound. So we can cancel any option that contain number 1. Number 2 says that it is a mixture of elements and compounds. This is correct. Number 3 says that it contains only nonmetals. Argon here is nonmetal, carbon dioxide as well. Oxygen, nitrogen is also nonmetal. So option 3 is correct, giving us an answer of C. Next, question 3. A representation of an atom is shown. What is the nucleon number of this atom? Nucleon number is the total number of proton plus the neutron in the nucleus of an atom. So the center here is the nucleus of the atom. Protons are positively charged and neutron here has no charge, meaning that the gray particles will be the neutron. So you have 1, 2, 3, 4, 5, 6 and 7 neutrons, and you will add up with the number of protons present in the nucleus, which is 1, 2, 3, 4, 5 and 6. Adding up together will give us 13. So the answer here is D. Question 4. The percentage abundances of 3 isotopes in a sample of neon are shown. Isotopes are elements that have the same proton number but a different nucleon number. What is the relative atomic mass of this sample of neon? When you are asked to look for relative atomic mass given the percentage abundance, you can do it by a simple calculation, whereby you will take the percentage abundance and multiply it by its nucleon number Add them all up together and divide it by 100. Just put these values in your calculator and you will get 20.19. So the answer is B. Next, question 5. Potassium reacts with iodine to form potassium iodide. Potassium will be written as K. Iodine is from group 17 and they present as a diatomic molecule. So don't forget to write 2 over here and they will form potassium iodide. The charge of potassium is +1 and the charge of iodine is -1. To get their formula, we will use their charge and cross them out to get the molecular formula. So the molecular formula is Ki. Now if we were to balance it, there is a 2 for iodine, so I'm going to put a 2 here, making 2 potassium and balance it with another 2 here. Next, which statement about potassium iodide is correct? Option A says that each potassium atom shares a pair of electrons. This is wrong because potassium is a metal and iodine is a non-metal, making this an ionic bond. An ionic bond donates an electron and gains the electron to become stable. Option B, in potassium iodide, the particles of potassium have more protons than electrons. So in potassium iodide, the particles of potassium has donated 1 electron. Potassium atom has 19 electrons and 19 protons. But after donating 1 electron, it is left with 18 electrons and the proton remains the same. So yes, this statement is correct. The answer is B. Question C. Which substance has the lowest melting point? There are 2 types of compound that you will learn. The first one is an ionic compound and the second is a covalent compound. Ionic compound has high melting point and boiling point. In covalent compound, you have a simple covalent compound or a giant covalent compound. A simple covalent compound has a low melting point and boiling point, whereas a giant covalent compound has high melting point and boiling point. So the lowest melting point will be a simple covalent compound, and a simple covalent compound is methanol. Next, question 5 onwards is from chapter 2. Which statement describes a property of potassium iodide? Potassium iodide is an ionic compound. It can be soluble in water. This is not volatile, as volatile substances are usually alcohol. An ionic compound has a high melting point. And yes, it can conduct electricity only when it is molten, because in this state there will be free moving electrons. So the answer is D. Next, question 6. Methanol has a boiling point of -19 degrees Celsius. At 20 degrees Celsius, the liquid methanol is non-conductor of electricity. In a sample of methanol, each atom of carbon, hydrogen, and oxygen has noble gas electronic configuration. Noble gas electronic configuration means that the outer shell has complete full 8 electrons. Each atom has achieved this electronic configuration in one of these 3 ways: gaining, losing, and sharing. Which statement describes the bonding between the carbon atom and oxygen atom in methanol? So I'm just going to draw this out for you of how it looks like. There are 2 hydrogens, 1 carbon, and 1 oxygen. Hydrogen have 1 electron on its own, and it's going to need another electron from carbon to be stable. Oxygen has 6 electrons on its own, and it's going to need 2 from carbon. So now carbon have 1, 2, 3, 4, 5, 6 only. So we're going to move the 2 electrons here into carbon to be shared with. Now each of these atoms will have complete 8 electrons. So the first statement A says that the carbon atom, this, and the oxygen atom share 4 electrons. These are 4 electrons. So the answer is A. Next, question 7. The structures of diamond and graphite are shown. Which statement about diamond and graphite is correct? Diamond and graphite contain strong covalent bonds between the carbon atoms. This is correct. Diamond and graphite have delocalized electron is wrong. They actually cannot conduct electricity due to not having free moving electrons. Diamond and graphite has layered structures. No, they don't. They have giant covalent structures. And diamond and graphite actually have a high melting point due to its many covalent bonds that require a high amount of energy to break them. Next, question 8. Which row contains a description of metallic bonding and a property that is explained by reference to the metallic bonding? Metallic bonding has a lattice of positive ions and then delocalized electrons. So option A and B is wrong. So the property explained by reference to the metallic bonding says that a metal will react with an acid to produce hydrogen. This statement is correct. However, it is not in reference to the description being said over here. The description here talks about the lattice structure, which when hammered allows the layer to slide over each other. So when they can slide over each other, they can be molded into different shapes. So the answer is D. Alright guys, that's all for this video. Thank you so much for watching. Please subscribe to my channel if you find this helpful. For the next video, I'll be discussing on Chapter 3 Stoichiometry.